In this video, we will explore the WebSocket Protocol. WebSocket Protocol enables full-duplex communication over Transmission Control Protocol, that is, TCP connections. Let's compare WebSockets with Hypertext Transfer Protocol, that is, HTTP. WebSockets use persistent connections and enable full-duplex communication for real-time data transfer, which leads to lower latency and smaller header size. Ideal use cases include live chat applications, real-time dashboards, collaborative editing, gaming applications, and financial trading platforms. On the other hand, HTTP uses stateless connections with a request-response model. Every request creates a new connection, resulting in higher latency and larger header size. Ideal use cases for HTTP include static content delivery, representational state transfer, that is, RESTful application programming interfaces, or APIs, form submissions, traditional web browsing, and occasional data updates. Now, let us discuss the WebSocket Handshake process for establishing a WebSocket connection. In Step 1, the client sends an HTTP upgrade request to establish the WebSocket connection. The code shows an example of such a request. Notice the upgrade to WebSocket, the connection upgrade, the secure WebSocket key, and the secure WebSocket version headers. In Step 2, the server acknowledges the upgrade and completes the handshake. The code here shows an example of the server's response. The server's response header also contains the upgrade to WebSocket header and the connection upgrade header. Also, it contains secure WebSocket accept header. In Step 3, after a successful handshake, the HTTP connection is replaced by a WebSocket connection using the same underlying TCP or Internet Protocol connection. Both the client and server can now send data independently. Let's take a look at a WebSocket client implementation. The code displays a JavaScript client example. It begins by creating a new WebSocket connection using the WebSocket constructor, with the WebSocket address passed as an argument. It then adds an event listener for the open event, which occurs when the connection is established. When the connection is opened, it sends a message "Hello server." Additionally, it adds an event listener for the message event, which occurs when data is received from the server. The received message is then logged to the console. Key components of the WebSocket client include the WebSocket constructor, event listeners for connection states, methods for sending and receiving data, and error handling mechanisms. Important client events include open, when a connection is established, message when data is received, error, when an error occurs, and close when the connection is closed. Now, let's examine a WebSocket server implementation using Node.js. The code begins by importing the WS library. Then, a new WebSocket server is created, listening on port 8080. A connection handler is defined to manage new connections. When a client connects, a message is logged to the console. A message handler is defined to handle incoming messages from the client. When a message is received, it is logged to the console, and the server sends back an echo response to the client. Server features include event-driven architecture, connection management, message broadcasting, client tracking, and error handling. Common server libraries for various languages include the WS and Socket.io for Node.js, WebSockets and Autobahn for Python, Java WebSocket and Spring for Java, Signal R and WebSocket Sharp for C#, and Gorilla WebSocket for Go. Now we will discuss the WebSocket frame structure. The diagram shows the basic structure of a WebSocket data frame. The frame starts with a final fragment flag, followed by 3 reserved bits, and then the opcode. Next is the mask bit followed by the payload length. After that is the extended payload length, which is optional. Then there is the masking key, which is present if the mask bit is set to 1, and finally the payload data. Key frame fields include the final fragment flag, the reserved bits, the opcode, the mask, and the payload length. Opcodes include 0 times 0 for the continuation frame, 0 times 1 for the text frame, 0 times 2 for the binary frame, 0 times 8 for the connection close, 0 times 9 for the ping, and 0 times A for the pong. Now we will learn about WebSockets design patterns. The publish-subscribe pattern involves clients subscribing to topics or channels and receiving messages published to those channels. As shown, a client subscribes to a channel on the server. The event-driven pattern involves the server pushing events to clients based on system changes or triggers. As shown in the diagram, the client and server can both send and receive events from each other. The code shows a server-side implementation of the publish-subscribe pattern using Node.js. The code begins by importing the WS library and creating a new WebSocket server. It then tracks subscriptions using the channel's object. When a client connects, the connection handler parses incoming messages. If the message type is subscribe, the client is added to the specified channel. Let's explore best practices and common challenges when working with WebSockets. Best practices include implementing a heartbeat mechanism, using secure WebSockets, that is, WSS://, handling reconnection gracefully, implementing proper error handling, and optimizing message size and frequency. Important security considerations include validating all incoming messages, implementing authentication using transport layer security, that is TLS, or secure sockets layer, that is SSL encryption, protecting against cross-site WebSocket hijacking and rate-limiting connections and messages. Common challenges include connection stability over unreliable networks, scaling WebSocket servers, handling connection timeouts, browser compatibility issues, and proxy and firewall traversal. Fallback strategies include long polling, server-sent events, HTTP version 2 server push, using libraries like Socket.io that handle fallbacks, and adopting a progressive enhancement approach. In conclusion, WebSockets provide powerful real-time communication capabilities that enable a new generation of interactive web applications. By understanding the protocol fundamentals and following best practices, developers can create robust and efficient real-time systems. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.